Alright, in this video we're going to be talking about how to find the asymptotes of a rational function, right? So we'll talk about both the vertical and the horizontal asymptotes and how we can figure out where those are. And we'll also do an example where we actually take a rational function and find its asymptotes. Alright, so first off, if we're given a rational function, r of x, which remember, a rational function is two polynomials in a fraction, one in the numerator, one in the denominator. So the first polynomial is a sub n x to the n plus blah blah blah, and then the second one, the one in the denominator, is b sub m x to the m plus all those other terms. Right? So remember, polynomials are the a sub numbers and the b sub whatever. Those represent just the coefficients, the numbers in front of the x's, and then the n and the n minus 1, those represent the powers of x. Right? Remember, for a polynomial, the exponents have to be positive whole numbers. Right? So that's what all that is up there. All right, so we have one polynomial over another. If I want to find the vertical asymptotes, right, the vertical asymptotes are going to be where our denominator equals 0. Right? So the vertical asymptotes are the lines x equals a, where a is a 0 of the denominator. Right? Remember, 0 means a number that when you plug it in, it equals 0. Right, so the thing about vertical asymptotes, and if you didn't watch the video that I did just in the general information about asymptotes and about rational functions, we talked about the definition of a vertical asymptote. A vertical asymptote is a vertical line where the graph either approaches positive or negative infinity on either side of that line. And on that vertical line, the graph does not exist. Well, for a rational function, for a fraction, that does not exist where your denominator is equal to 0. Right, and if you think about things that we did, if you watch some of the other videos I did about like the domains of functions and things like that, for a rational function, when you have a fraction, when you find your domain, the denominator is not allowed to equal 0. Right? Well, for rational functions where you have those vertical asymptotes where the function does not exist, well, it does not exist where your denominator equals 0. Right, so again, trying to tie things into the things that you should have learned previously, the domain of a function and stuff like that. Where your denominator equals 0, the function does not exist. Where the function does not exist, you have your vertical asymptotes. Right? So, when I want to find vertical asymptotes of a rational function, what I do is I take my denominator, I set it equal to 0, and then I solve it, and whatever values I get, that's going to give me my equations of my vertical asymptotes. All right, so that's where we get the vertical asymptotes, is where the denominator equals 0. And then for the horizontal asymptotes, what we do for the horizontal asymptotes is we compare the degrees of the numerator and the denominator. So if you recall, degrees, when we're talking about polynomials, the degree is the highest exponent that you see in that polynomial. Right? So for my numerator, the degree is going to be n. Right? It's going to be that highest exponent that I see in the numerator. For my denominator, the highest degree is going to be m. Right? The highest number that I see as an exponent in my denominator. So to figure out where the horizontal asymptotes are, all I do is compare those two numbers to each other. Now, there's three ways that could go. The top one could be bigger, the bottom one could be bigger, or they could be equal to each other, right? And that gives us three different cases of what could happen for our horizontal asymptotes. Right, so for the first case, if n is less than m, right, which means I have a smaller power in the numerator and a bigger power in the denominator, then my horizontal asymptote is the line y equals 0, which is the x-axis. Right, so if you have a smaller exponent on top and a bigger exponent on the bottom, your horizontal asymptote is y equals 0, it's your x-axis. If the two powers are equal to each other, right, if the two degrees are equal, if n equals m, then your horizontal asymptote is y equals a sub n over b sub m. Right, so if these two exponents, the highest exponents we have in the numerator and denominator, are equal, then I take those leading coefficients, those numbers in front of those terms with the highest exponents, and I put those into a fraction, and y equals that number. That's where that horizontal asymptote is going to be. And then the third case is if n is greater than m. If I have a bigger exponent on top and a smaller exponent on the bottom, in that case, I don't have a horizontal asymptote at all. All right, so these rules can get a little confusing. Sometimes it's hard to keep them straight as far as which is which. So there's a way that I think about it that hopefully will help you to remember what these rules are. I think about it as kind of like a fight between the numerator and denominator for control of this overall function. Right, we have this rational function with a numerator and denominator, and the numerator and denominator are fighting against each other to see which one takes control of this function as x goes off towards infinity and x goes off towards negative infinity. Right? Remember, the horizontal asymptotes is what happens way off on the right of the graph and way off on the left. Right? So in the middle of the graph, like all kinds of stuff is happening as the numerator and denominator struggle with each other. There's all kinds of ups and downs and curves and stuff. But as you go off towards the infinities, the leading terms here are going to be the ones that determine what happens. Right, so think about them as fighting against each other. Well, if the top one is stronger, right? So if n is bigger than m, right? So meaning my numerator is stronger, it has a higher power than my denominator. Well, that's going to pull the graph upward, and it's going to go off towards infinity. It's not going to have a horizontal asymptote. Right? So if my numerator is stronger, it has a higher power. The numerator pulls the graph upward. It doesn't like settle down to a single line. It pulls it up, and it goes off towards infinity. All right. If n is less than m, right? So if my denominator is stronger, if my denominator has a higher power, well, then the denominator is pulling the graph downward, and it's going to settle down to the x-intercept at y equals 0. Right? So a stronger denominator pulls the graph down to 0, right? So it pulls it down to y equals 0. Now, if the two are evenly matched, right? If I have the same power on the top and bottom, they're still struggling against each other, but neither one can really overcome the other. That's when those leading coefficients come in, right? That's when they're perfectly balanced. So whatever those numbers are in front, those numbers are now going to determine where your horizontal asymptote is, right? It's just the top one over the bottom one. That's where you get your horizontal asymptote. All right, so that's the way I envision the horizontal asymptotes for a rational function. Maybe I'll have a violent mind. I envision it as the numerator and denominator fighting against each other. But if you keep that in mind, it could help, right? A stronger denominator pulls it down to 0. A stronger numerator pulls it up, and it goes off towards infinity. When they're evenly matched and they're struggling against each other, those numbers in front determine what goes on. All right, so those are the rules for how to find vertical and horizontal asymptotes. So I'm going to pause the recording here and erase all this and put up an actual rational function, and we'll go ahead and we'll find the vertical and the horizontal asymptotes. All right, here's the example we got. Our rational function r of x equals 3x squared minus 2x minus 1 over 2x squared plus 3x minus 2. And I want to find the vertical and the horizontal asymptotes of the graph of this function. All right, so let's start with the vertical asymptotes. If you recall, the vertical asymptotes, the function does not exist on those vertical asymptotes. They occur where your denominator is equal to 0, right? Because those points will not be in the domain of the function. And when we want to find the domain of a rational function, we set the denominator equal to 0. So those two things are very closely tied together here. All right, so if I want to find my vertical asymptotes, which I usually just abbreviate VA because both vertical and asymptote are kind of long words to write, and I am in essence a lazy person. So vertical asymptote VA is not equal to. The vertical asymptote is going to occur where my denominator, 2x squared plus 3x minus 2 equals 0. All right, so to find the vertical asymptote, I set my denominator equal to 0, and now I need to solve this equation for x, and now it comes into, well, what algebraic techniques do I need to do in order to solve this equation? All right, so recognize what type of equation it is. We have an x squared, so it's a quadratic equation. So our methods for solving quadratic equations are the square root method, factoring, and the quadratic formula. All right, so one of those we're going to have to use to solve this equation. It looks like probably we can factor this. The numbers look pretty agreeable here that we should be able to factor it. So let me see if we can factor it. And if factoring doesn't work, I'll go ahead and use the quadratic formula. So 2x, x, probably a 2 and a 1 and a plus and a minus. So it's going to be 2x squared plus 4x minus 1x is plus 3x and then minus 2. All right, so there's my factoring of this one here. And if you, I just kind of did that quick because this is not a factoring problem. It's a problem of finding the asymptote. So I'm not going to spend a long time belaboring how to factor this. If you don't understand how to factor this expression and get these factors here, I did some videos on factoring, so you might want to go back and watch some of those videos and kind of review how to factor. Factoring is something that comes up a lot when you're dealing with rational functions. So if you don't have those factoring skills, you should probably bone up on the factoring and review it because it comes up all the time when you're dealing with rational functions. All right, so I factored. My two factors equal to 0, so I set each one individually equal to 0. 2x minus 1 equals 0, x plus 2 equals 0. The one on the right is easy. If I subtract 2, I get x equals negative 2. On this one, if I add 1 over, I get 2x equals 1. Then if I divide by 2, I get x equals 1/2. Right, so here are the equations of my two vertical asymptotes. Right, the graph of this function is going to have two vertical asymptotes, x equals -2 and x equals 1/2. Right, so that's where I'm going to have those vertical lines that the graph, either goes up towards infinity or down towards negative infinity on either side of those two vertical lines. All right, so that's finding the vertical asymptotes. Sometimes you get two vertical asymptotes, sometimes you get three, sometimes you only get one. It really depends on the degree of your denominator. If your denominator is just a linear function, if it was just like 3x minus 2, well, when I set that equal to 0 and solve it, I'm only going to get one answer, so that function would only have one vertical asymptote. Right? This one was a quadratic function, so I end up with two vertical asymptotes. All right. So those are my vertical asymptotes. I'm going to pause this recording again and erase the stuff that's up here so that we can then do the horizontal asymptotes. All right, so I erased all that work we just did for the vertical asymptotes. I put our answers up here just so we remember where our vertical asymptotes are. But now we're going to try to find the horizontal asymptote of our graph, of our function. All right, so remember, for horizontal asymptotes, what we do is we compare the degrees of our numerator and denominator. Right, so for the horizontal asymptotes, I only am concerned with the leading terms, which is the 3x squared in the numerator and the 2x squared in the denominator. Right, those are the only things I need to care about when I'm trying to determine the horizontal asymptotes. Because as x goes off towards infinity, the reason we only care about that leading term, as x goes off to positive or negative infinity and the x values get really, really big, well, if I'm plugging in like x equals 17 million, well, when I subtract 1 from that, it hardly changes the value at all, right? Or if I subtract 2 from that, it doesn't really change the value that much. So as x gets huge and huge and huge, these -1 and -2 become pretty much just insignificant. Even this -2x and this plus 3x, if I do 3 times 17 million squared, that's a ridiculously huge number. That -2 times 17 million is really small in comparison. So these other terms, as x goes towards infinity or negative infinity, they basically just become irrelevant. And these leading terms, the one with the highest exponents, they determine what the function is going to do, right? Because when I take those huge numbers and square them, that has a bigger effect on the overall value of the function than this other stuff over here. All right, so that's why we only care about that leading term. All right, so to find the horizontal asymptote, which again is as x approaches positive and negative infinity, I compare my leading terms, I compare the degrees. So in the numerator, I have degree 2. In the denominator, also degree 2. Right, so there's three different things that can happen. The numerator's bigger, or the denominator's bigger, or they're equal to each other. Right, and those three different cases give us three different results for the horizontal asymptote. So in this case, where the two are equal, right, so for my horizontal asymptote, basically I have a 3x squared over 2x squared, right, if I'm just looking at those leading terms. Right, so since these two are equal, they basically just knock each other out, right? They're evenly matched. If you think about it as like a fight, the x squared and the x squared are evenly matched. So what determines what happens here is then the 3 and the 2. Right, so my horizontal asymptote is going to be y equals 3/2. And that's it. Finding the horizontal asymptote, if you know those three basic rules, is not hard to do. Right, so the exponents matching my leading term, y equals 3 over 2. I just take those leading coefficients. That's where I get my horizontal asymptote. That's it. All right, so if this had been like an x to the third on the top and an x squared on the bottom, then I would not have a horizontal asymptote, because if the top is stronger, if it has a higher power, it's pulling the graph up, and the end of the graph is going to go off towards infinity. Right? Remember, if the denominator is stronger, if I had like an x to the 5th power down here and still an x squared up top, if the denominator has a higher degree, a higher power, it's going to bring the graph down. The denominator pulls it down to y equals 0. Right? In this case, though, since they were evenly matched, I get y equals 3 over 2. All right, one last thing I'm going to do. I'm going to graph this function just to confirm on my calculator that I got the right asymptote. So notice, though, when you type in a rational function to graph it, you have to put the entire numerator in parentheses and then the entire denominator in parentheses. Right? If you don't use those parentheses, your calculator could mess things up. And it's not that your calculator messes things up, it's that you messed it up by typing it in wrong. Right? So you have to use entire numerator, entire denominator, both in parentheses. And when I graph that function, here's what I get. Right? So notice, as I kind of get closer to the screen here, my vertical asymptote's at -2. So over here, where the graph goes up towards positive and negative infinity, that's at x equals -2. And then over here, same thing happens, that's at x equals 1/2. So those are my vertical asymptotes. And my horizontal asymptote off on the negative infinity side, and then over here towards positive infinity, that's going to be at y equals 3/2, right? Or y equals 1.5, right? So looking at the graph kind of confirms that the work we did is okay, right? So that's how you find vertical and horizontal asymptotes for rational functions.